Hello guys. How are you? Can you hear me? Mm,
Yes.
Okay. Okay, perfect. Okay guys, so I'm going to just go to get into the session immediately because it's a long one. So first I want to tell you the things that are going to be included in your exam. You have 4 lessons that will be included in your exam. The first one is electricity from the second trimester, and rocks and soil or rocks and minerals also from the second trimester. From the third trimester resource pack, we're going to take only 2 lessons, which are the magnetism and heat. Force is not going to be included in your exam. So those are the things that going to be in your exam, okay? Today we are going to start by revising the electricity, and we're going to go through the PowerPoints that we were using throughout the second trimester. Can you see the PowerPoint?
Yes.
Okay. We're going to start with this this PowerPoint first. We're going to go through as much as possible from the PowerPoints of the electricity, and then we're going to answer the final practice worksheet together, the part related to the electricity, okay? So now we have matter, and we know that the matter has smaller particles inside it, which makes up the matter, and those smaller particles are called atoms. Do you remember this?
Yes.
Okay, and inside, okay, inside the atoms there are two kinds or two kinds of particles. There are positively charged particles and there are negatively charged particles, which are much smaller and they revolve or they move around the positively charged particles. Okay. The positive and negative charge inside any atom, they act like the north and the south pole of the magnet, meaning that if we approached 2 positive charge to each other, they act like 2 north sides or 2 south sides of the magnets are getting closer to each other. In this case, what will happen? Will the positive charge repel or attract? Whoever knows, please raise your hand. Sorry. If I brought 2 positive charge closer to each other, yes, Omar?
Positive.
The positive and positive, will they repel or attract?
Repel.
Repel, very good. But if they are positive and negative, of course, they will attract. Okay?
Attract.
Yes, thank you. Habiba?
No, nothing.
Okay. Now let's continue. Fayrouz, yes, Fayrouz.
Miss, sorry, which page?
No, dear, we are revising the PowerPoints that we were using during the second trimester. Okay? Yeah, okay. Now you can turn off your video. The positive and negative charges are like the north pole and south pole of a magnet, as I told you. So if 2 different sides are facing each other, they will attract. If 2 similar size, similar kinds, they will repel. Okay, now I need someone to count the numbers of the positive charge and negative charge in this atom. Whoever knows, please raise your hand. Hey. Let's take Hannah Muhammad. Yes, Hannah.
No, Miss, I wanted to ask a question, but now I don't.
Who wanted to ask a question? فيروز؟
No.
اوكي. اوكي، احمد مروان. احمد مروان. Can you hear me, dear?
7 positive and 7 negative.
Thank you very much, Ahmed. 7 positive and 7 negatives. Negative. And this will make us reach the next point, which is that any atom in the world is always neutral. What is the meaning of neutral? It's not positive nor negative. Why? Because
Miss Mariam, no, she raised her hand.
okay. Because this means neutral. The neutral means that it's not positive or negative. Okay, the ones who are raising their hands, do you have a question or do you want to answer something? Hannah. Yes, Hannah.
I want to answer.
Okay, when I have a question I'm going to make you answer. Okay, Hannah? Yes, Fayrouz.
Miss, now I won't find it in the book because I'm looking down the book and I cannot find it.
Find what, dear?
The pages that you are reading down.
The pages I'm reading down is from the PowerPoint, Fayrouz. It's not from a book, honey.
Yes. Okay.
Okay.
So I won't find it in the book?
No, you will find it in the, you will find what I am talking about in the second trimester book. Okay, but you will not find this exact slide because this is my PowerPoint. You understand?
Yeah.
Okay. When the number of positive charge inside the atom is equal to the number of negative charge inside the atom, which is the case always, this means that the whole atom will be neutral, which means that it's not the atom itself, it's not positive nor negative, because each positive charge inside the atom held hand with a negative charge inside the atom too, and they are equal in number. So this makes the atom, we cannot call the atom negative or positive because the number of positive equal the number of negative. Okay, guys, so we call it what? We call it neutral, which means that it's not positive or negative. Okay, which charge do you think will move easily inside an atom? So it's very obvious that the negative charge is much smaller and has more space in order to move more freely. So the negative charge is the one inside the atom which is responsible later when we know of electricity. It's the one that moves from one place to another easily. So this is what causes the electricity. Okay. Now, if we have a balloon and we are rubbing the balloon against a piece of cloth, the negative charge from the piece of cloth will start to jump or build up on the balloon. It will start to like fill the balloon. Like if you have a backpack and you want to fill it with books, the books are the negative charge. You are trying to fill the backpack with books. This is the same case in the negative charge. When you are rubbing the balloon against the piece of cloth, this means that the negative charge are packing on or are building up on the balloon. Okay. Now, when you bring this balloon and you put it next to your hair, what will happen? It will get stuck to the positive charge in your hair, and this what will make your hair will stick to the balloon, because the negative charge in the balloon are attracting the positive charge in your hair. So far, anyone is confused about anything, guys? If you are, please raise your hand. Okay, very good. Now, the meaning of static yes, Ahmed?
I'm confused about the balloon part.
You're confused about the balloon part?
Yes.
Okay. So you have a balloon and you start rubbing it against a piece of cloth, okay? You are rubbing it against a piece of cloth. The balloon and the piece of cloth has both the positive charge and negative charge, okay? So when you are rubbing the balloon against the piece of cloth, the negative charge from the piece of cloth starts to jump to the balloon, okay? Now you will bring this balloon and put it next to your hair. When you do this, Ahmed, your hair starts to rise, right or wrong?
Yes.
Yes, this is because your hair has a positive charge, and right now when you rub the balloon against the cloth, you filled the balloon with negative charge. When we approach negative charge to a positive charge, what happens to them? Will they attract or repel?
They will positive charge and negative charge together.
Yes,
They will attract.
they will attract, and this what causes your hair to get stuck to the balloon and rise up with it. Do you understand now?
Okay.
All right, Yusuf.
Entered and I don't understand what you were talking about.
What?
I just entered and I did not understand.
Okay. We are revising the PowerPoint of electricity.
Okay.
Okay. So the build up of turn off your video, please, Yusuf. The word build up, it means that we are filling or we are packing up something with negative charge, okay, or the same kind of charge. But mainly in electricity, it's negative charge because the negative charge is the one that is moving easily, okay? So now we have, again, the backpack and books. We are putting the books inside the backpack. We are building up the books inside the backpack. Or when you have like, for example, Lego parts, and you are trying to stick them to each other, so, and to make a long tower. This is building up of the Lego parts in order to make this long tower. So build up has more of a kind of charge than other. If you have, for example, a bag that you will add books and apples to it, you add like 10 books and 3 apples. Which kind of objects are more inside the bag, the books or the apples? Someone please raise your hand so that you can answer the question. Yes, Omar.
The books.
The books. So this means that I am building up the bag with books, not apples, because the books are more than the apples, okay? Right. Now, this is what we call static electricity. Static electricity is the build-up of electrical charge on an object. Yes, Yusuf? Yes, Yusuf?
I just raised my hand to answer.
Okay. Yes, Omar, do you have a question?
Yes.
Yes. Okay. So the build-up of electrical charge on an object, this is called static electricity. And it's static because it does not move. As long as it's on the object, it will not move around, unless, of course, if you rub it against something. When you are building up the charge on an object, this is called a static electricity, okay? How do we see, or where do we see the static electricity? In case, of course, that, as I told you, you are rubbing the balloon against a wall of a cloth of wool, and it's filled with negative charge, and then sometimes if you just let it go on the floor, it will come closer to one of the walls of the room, and it will stick to it. Why? Because this way the negative charge and the positive charge will be attracted to each other. Yes, Yasin.
I wanted to answer.
Okay. If there is a question, I will let you answer. Okay. How do we experience the electric current, static electricity? If you are walking on a carpet, this is actually you rubbing against the carpet, and this way the negative charge from the carpet will jump into your body and you will be built up with negative charge. Then if you touched a doorknob or you are shaking hands with someone, you will get the buzz, or you will be shocked with the small electric shock due to this, because the negative charge in your body are actually jumping to the item that you just touched. Okay. This the jumping of negative charge from the body that is full of negative charge to the one that is positively charged is called a discharge. And you can see it also in the lightning. The lightning occurs due to the rubbing of the water droplets and the snow particles inside the cloud. They start to rub against each other, and this will fill the cloud with negative charge. Now the ground is always positively charged. So in this case, the negative charge from the cloud, when it reaches a specific point, there are too many, it will jump to the ground, which is positively charged, and this what causes the lightning. Okay. Now this is it for this PowerPoint. Do you have a question in the previous things that I just said? Any questions, guys, so far? Yes, Yusuf.
I have a question about how I don't understand how have you the last PowerPoint presentation, the last slide. I don't understand it.
What last slide?
In the PowerPoint, I don't understand that.
The lightning?
Yes.
Now the cloud, what causes the lightning? When the cloud is full of water droplets and snow particles, they start to rub against each other, and this will fill the cloud with negative charge. The ground is always positively charged, so the negative charge from the cloud are actually attracting to the positive charge in the ground, and that's what causes the lightning. They are like jumping from the cloud to the ground. Do you understand now?
Yeah, so you mean when there's water and in the cloud, when there's water and the snow, they rub against each other,
filling the cloud with
becomes negative energy. Then the negative energy,
negative charge, not negative energy, negative charge.
Negative charge, and the ground's positive charge. When they hit each other, it makes lightning.
Yes. Okay, so now we are going to remember together the parts of the circuit. But first, what is the circuit? Anyone has a question? Yes, Yasin.
How does the negative energy jump so hard?
How do they jump so hard? I can't hear you, Yasin. Can you raise your hand, raise your voice, please?
Energy jump so high.
Jump so high?
Yes.
Yes, because it moves easily. It can jump whatever height it is. Okay?
Okay.
Omar? Yes, Omar.
I wanted to answer the question.
Okay. Who's Jude Hamid?
Jaden.
This is Jaden? Yes, Jaden. Do you have a question? Do you have a question, Jaden? No? Okay. Jude, Yusuf, Karma, Anyone has a question?
No.
Okay. Now let's continue.
Miss, I have.
Yes, Yusuf.
Miss, I want to show you something that I was working on about the magnet. I made it
Okay,
in
we need to finish, Yusuf. I'm sorry, I'm very, very sorry, dear, but we are short on time and we need to finish revising. Okay? If we
I
have
have a
time,
circuit.
if
I
we
have a
have
circuit.
if we have time at the end of the session, I'm going to see it. Okay?
Miss, I have circuit. I have a circuit.
Okay, dear. Okay, so the electricity, we talked about the static electricity. There is another type of electricity which we call the current electricity. And it actually not like the static, it's not staying in one place. No, it actually moving or flowing around, like the river, the water flows in a river. It's called the current electricity or electric current. Okay. The source, yes, who's raising their hands? Omar, yes, Omar. Okay, Jayden. Okay, dear. Jayden. Okay, so the power source or the socket you find inside or in on your wall, this is the places where you get the current electricity from. As you can see, this we cannot call it a circuit. Well, in this case, will the bulb light? Yes or no? Yes or no? Yes, Omar.
It will light.
It will light this way?
No, no.
Oh, it will not light. Why?
Which way?
It's not complete. There is a missing part. What?
Oh,
what
because there isn't the circuit is incomplete, so the electricity will not.
Yes, it's incomplete and it's missing a part. What part is this circuit missing?
Battery.
The battery, exactly. The power source. Very good. Now, Ruqayya, I want you to answer this one. Will this bulb light?
Switch bulb.
Can you see it, dear?
No,
You're not seeing it? Okay.
no.
Miss, there is no bulb. There is no
Can you
bulb.
see it now?
Yeah.
Okay. Will this bulb light?
Well,
No. Why?
because there is no circuit.
Yes, there are no wires. There are no wires connecting the bulb to the power source, right?
No.
Okay. The next one, Karma, can you tell me, is there a bulb aslan?
No.
No. So this is an incomplete circuit, so nothing will light up actually. Okay. So this is the circuit and this is the main parts of any circuit. Ruqayya, do you have a question? Okay, Karma, do you have a question?
No, I just wanted to answer.
Okay, when
And
there
then
is
I forgot.
Okay, okay. Habiba, do you have a question?
I wanted to answer.
Okay. Muhammad Wael.
I wanted to answer too.
Okay. Jayden.
Miss,
Yes.
did you receive my project?
Yes, I did. I will be viewing them today, inshallah.
What did Khalid do?
Okay. Yes, Ruqayya.
Miss, did you see my project?
I received it. I'm going to see it today, يا رقية.
Miss,
Yes. Yes, Maya.
Miss, in the project, do we have to write the question and under it the answer?
No, you can write a headline and under it the information that you collected.
Miss,
Okay?
Miss,
Yes, Muhammad.
I did not understand the project.
You did
Are
not.
Are we going to do it in a video or a PowerPoint or?
You didn't attend the last session, ya Muhammad?
I attended it, but I didn't understand it very well.
Yes, you're going to do it in a PowerPoint. You're going to answer the questions that I gave you, and you're going to do it in a PowerPoint. And then there is a video that I uploaded for you on the stream that has an experiment in it. You're going to do the experiment and take pictures of yourself doing it, and then you will upload it to the PowerPoint too.
Okay.
Okay. Yes, Karma.
Miss, when is the due date of the project?
It's May 28th, but I will accept it until the Sunday after the Eid week.
Okay, thank you.
You're welcome, dear. Yes, Yusuf.
Is there any slides you want in the project? Numbers?
Numbers of what, dear?
Slides.
No, a specific number? No. Okay?
An experiment video ولا
No, take pictures. No. Take pictures of yourself doing it. It's not it doesn't have to be a video.
One picture
No,
or more?
I said in the rubric, if you open the rubric, the video that I included, you will find that I said that if you added pictures of every step you're doing and the final conclusion, this will give you the full mark. If you added only one, this will make you lose marks.
Okay.
All right. Any more questions? Okay. So this is a circuit, and the circuit parts are made of bulb and a connector. This part, it does not have to be bulb. Any load, a bulb, a buzzer, a motor, all of those loads could be a part of the circuit. And the connector, of course, which is the wire, and the power source, which is the battery or the cell. Okay? Now, as I told you, this is the simple circuit. It contains those parts. And then there is another things. Yes, nice, Yusuf, very nice. There are other parts that could be added to the circuit. Like, for example, the switch. Do you remember the switch? It makes us control the flowing of the charge inside the current, the circuit that we did. It could be, we could add a switch in order to control it. Yes, Yasin. Yes, Yasin. Okay, guys. We need to move quickly because we are, yes, Fayrouz.
Yes. Sorry, I was keeping on leaving a comment because there was a problem and I solved it.
It's okay. Oh, it's okay. Okay, guys, in a
But I didn't hear anything.
Okay, we're going to answer the questions and it will help you see the rest of the things, okay?
Okay.
Okay, guys, in a circuit, if you added more cells or more power source, this will make the bulb light brighter or dimmer? Hannah Muhammad, can you tell me? Hannah Muhammad.
Miss, what is the question again?
The question is, if you added more power source or more batteries to your circuit, will it glow brighter or dimmer, the bulb?
Brighter.
Yes, brighter. But if you added more bulbs, it will light dimmer. If you used a longer wire, it will light dimmer because it will take too much time in order to reach the load. But if you use the shorter wire, it will light brighter. Okay. Now, as for the symbols that we are using for the circuit, these symbols help us to make it easier for us to make the circuit. The bulb is, of course, the circle with cross inside it. The wire is the straight line. Switch off is this shape, and when it does not, the ends does not meet, it will be off or an open switch. And if they are touching each other, it's a switch on or a closed switch. This is the buzzer, and of course, this is the bell. You did not take the bell, and it's not really important, so just you don't have to
The
know
bell is like a
about it.
buzzer. The bell is a little bit like a buzzer.
Yes, it looks a little bit like a buzzer, yes. The motor is the circle with an M inside it. This is the cell, and the shorter side is the negative charge. The longer side is the positive charge. Okay, guys? So this is it for this PowerPoint. Let's see the next one, the next PowerPoint. Part 3. What's part 3? Okay, so this is when we talked about the insulators, and you can see this, guys?
Yes.
Okay.
Yes.
So this is when we talked about the insulators and conductors and went to the lab, and we tried different types, and we said that all the metals are electric conductors, but any other object is electric insulator, like the plastic or the rubber or the wood. But we said that there is one non-metal which is not, which is an electric conductor, which is what? Do you remember? Something.
Miss,
Who is talking? Who's asking? Okay, guys. So there is a specific non-metal, something that is not metal, but it conducts electricity. Do you remember its name, Habiba?
Graphite.
Graphite, very good. The graphite is the tip of your pencil, the part in your pencil that you write with. This is the graphite. Very good, Habiba. Thank you very much. Now we are going to talk about the parallel and series circuit. And we said that the series circuit is when we put the all of the parts of the circuit next to each other like a series of things. But when you add the bulbs in a parallel circuit, it's like they are they are all not in the same path, not like the series circuit. In the series circuit, all the parts are in the same pathway, but the parallel circuit, they are not in the same pathway. Now, I will ask you a quick question before we go and answer the practice worksheet. If I have a series circuit and I remove one of the bulbs, like this one, if I removed one of the bulbs, the rest of the bulbs, will they go off or will they still be on? Hey, Yassine, can you answer this question? Hey. Raise your hand, raise your voice, Yassine, please.
what's the question again?
Yes, in the series circuit, if I removed one of the bulbs, the rest of the bulbs, will they still be on or will they go off? They will go off. Why? Because all of them are in the same pathway. What about the parallel circuit? Huh? What about the parallel circuit?
No, it won't.
Okay, it will not. The bulb will stay on. If I removed one of the bulbs, the other bulb will stay on because they are in different paths, and this way the charge will reach the other circuit. Okay, now we need to answer the practice worksheet. So if you have your practice worksheet with you, you can open it now. Can you see it? Can you see the practice worksheet? Huh?
Miss, which practice worksheet?
The final practice worksheet.
Yes, miss, I can see it.
Yeah, okay. The final practice worksheet that I uploaded on the Google Classroom.
I can see it. Miss, is it a page or is it a sheet?
The final practice worksheet, dear. The one that I uploaded, not the one in your book, the one that I uploaded on Google Classroom. Okay? We're going to start with question number 9 because this is...
No, I don't have it. Miss, no, I don't have it.
It's in your Google Classroom. You can see it or upload it anytime, okay? Now let's start answering it and then you can find it on Google Classroom. The first, of course, in the exam, I'm not going to tell you to draw anything because we're online. It's going to be very hard to add a question of drawing, but we're going to add it just for you to refresh your memory, and of course to know the parts of the circuit in case you got a question in your exam that asking you about one of the parts of the circuit. So in this question, we're saying draw a circuit using all the below items. You need to add 2 batteries, 2 bulbs, and the switch off. Maya, I want you to tell me the battery symbol is?
A circle and the X inside it.
Very good. No, the batteries, not the bulbs.
The battery? Oh, it's a long line and a short line.
Very good. A long line and a short line. The bulbs are the circle with X inside it. The switch off. Will the LEDs be touching each other or away from each other, the ends?
Away from each other.
Yes, very good. So it should look this way. You have the switch off, the 2 batteries, and the 2 bulbs. Can you see it?
Yeah.
1 times 5.
Okay. Now the next one is the question number 10. Are these complete circuits? Put tick or X. Fayrouz, can you answer the first one, dear? Is this a complete circuit?
Yes.
Yes, it is a complete
Miss.
circuit. Very good.
Yes.
The next one, come on, Fayrouz, I want you to finish all of them. This
Okay.
is...
No.
No, it's not.
Because the wire is not complete.
Yes, this one.
No.
Very good. The next one.
Not me.
No, also.
No, it is complete, but actually there is a part that I am hiding right here now. Is it complete?
Yeah, complete.
Yes, it's a complete circuit. This one.
No.
Yes, it's missing a part. And what about this?
No.
No, very good. Okay, Karma, I want you to answer the table. Hi, Karma. Karma.
Miss,
Yes.
I had a problem in my phone.
It's okay. Tell me, the metal spoon, is it an insulator or a conductor?
Conductor.
Okay. Before I go, guys, because there is less than 1 minute, we're going to be cut off. The rest of the paper, I'm going to upload it in tomorrow's recorded session, okay?